Hello everyone, welcome to the course Geotechnical Engineering 2. So, in this lecture number 4, we will be trying to solve some of the numerical problems based on the stress system what we have discussed in the previous sessions. Okay. So, what type of problems we generally discuss is, as I have mentioned, one certain type of problems, say considering the entire two-dimensional body having principal stresses, the other one say another two-dimensional body having a normal stresses along with some shear stress on the surface. Okay. So, these two particular models we will be discussing, and we will try to solve one problem based on graphical representation. Let us look at this. So, this is the course outline. So, these comes under our first phase of basic mechanism of shear strength. Okay. So, let me just give a quick outline about what we have discussed in our previous sessions as we are solving the problems. Just try to make a note of these particular expressions what I am going to show now. Okay. Now, let us say initially in session 2 we have considered a two-dimensional body having the principal stress, minor principal stress sigma 3 along the horizontal direction and major principal stress sigma 1 along the vertical direction. So, we have obtained a particular failure plane which is inclined at an angle theta. Okay. So, for this particular plane, failure plane, we are trying to obtain the sigma and tau, that is normal stress and shear stress, and we have denoted it with a particular wedge. So, for this particular case, we have obtained sigma is equals to sigma 1 plus sigma 3 by 2 plus sigma 1 minus sigma 3 by 2 into cos 2 theta. Okay. So, this is how we obtain the normal stress on this particular failure plane. Similarly, we have obtained the shear stress, that is tau, on this particular failure plane, that is sigma 1 minus sigma 3 by 2 into sin 2 theta. Okay. So, this we have understood and derived in our previous session number 2. Similarly, in our previous session, session number 3, we have considered a similar type of homogeneous two-dimensional body, soil mass, and instead of sigma 1 and sigma 3, as these are not the principal planes, unlike this case, we have considered sigma x as the horizontal force and sigma y as the vertical force, and apart from that we have considered tau x and tau xy along the surfaces of this two-dimensional body. So, similar way we have considered a wedge with a failure plane making an angle theta ABC. So, for this also we have obtained two expressions for the shear stress as well as the normal stress on this particular failure plane. Okay. So, these are the expressions. For sigma we have obtained sigma x plus sigma y by 2 plus sigma y minus sigma x by 2 cos 2 theta plus tau xy sin 2 theta. So, if you look at these two expressions, these are almost similar up to this part, but there is an additional term tau xy sin 2 theta as there is a shear stress along the surfaces, okay, because this is not the principal planes. And similarly, we have obtained tau. Okay. So, that is tau is sigma y minus sigma x by 2 into sin 2 theta minus tau xy cos 2 theta. So, these expressions are obtained in our previous session based on the stress system diagrams what we have considered and the derivations what we have carried out. Okay. Just make a note of these for our further understanding. So, in the session number 2, I have given some of the assignment questions. Let us try to solve these questions only for our understanding. So, these are the numerical questions what I have given 1 and 2. So, let us try to solve the first one now. So, there is a principal stress at a particular point on a material having, okay, see here it is given directly, these are the principal stresses. That means principal stresses 80 kilonewton per meter square and 40 kilonewton per meter square. These two are given as the principal stresses. So, directly take sigma 1 and sigma 3. Whichever is highest, you take that as the major principal stress. So, sigma 1 is 80 kilonewton per meter square and sigma 3 is 40 kilonewton per meter square. Now, so what we need to determine here? We need to determine the normal, shear and resultant stresses on a plane inclined at an angle 30 degrees. That means on a plane inclined at an angle 30 degrees. That means here theta is directly given 30 degrees. So, we need to find out for this particular wedge failure plane AB, we need to find out the shear stress, the normal stress as well as the resultant stress. Okay. I hope this is clear now. So, I have just marked for our understanding the diagram as a wedge ABC. I did not consider the entire 2-dimensional body, but I have represented the stresses sigma 3 and sigma 1. So, this is 80 kilonewton per meter square, okay, and this sigma 3 is 40 kilonewton per meter square, okay. So, these two are given and theta is given here as 30 degrees. Okay. Using these we have to simply find out their sigma tau and resultant. So, this is how we obtain sigma tau and resultant. Initially we have the expressions for the principal stresses case. So, we can obtain tau and sigma, and then using these two we have to find out the resultant using these expressions. Okay. Try to solve them using these expressions and you will get some value. Okay. Furthermore, for our understanding I am just mentioning here. So, what happens is when you square and add these, we know that this is in the form of an equation of a circle. So, to obtain the Mohr circle radius as well as the center, okay, you can simply obtain by this expression. So, for this particular case the circle radius is generally sigma 1 minus sigma 3 by 2. Okay. So, sigma 1 minus sigma 3 by 2, and similarly the center is at a coordinates of sigma 1 plus sigma 3 by 2 comma 0. Okay. If asked to find out the radius as well as the center of the Mohr circle using analytical method, you may directly use these expressions. Okay. Now, so let us now similarly look at the other problem number 2. Okay. It is given here on a failure plane. So, directly it is given on a failure plane. So, I am just drawing the wedge here. So, let AB is the failure plane. So, it is given that on the failure plane in a cohesionless soil sample, okay, in a cohesionless soil sample. So, what is cohesionless soil? Cohesionless soil means one that is not having any bond. Example, sand. Sand is the soil which is not having any cohesion. So, that is why it will simply, if you drop a bag of sand, it will try to flow. But if you drop a bag of clay soil, what will happen? It will try to stick to each other. Since it is cohesive, it won't actually form a particular flow. So, that is why it is a cohesionless soil sample given. C is 0. Okay. Now, let us look at the other one. The normal and shear stresses are found to be, it is directly given on the failure plane. The normal and shear stresses are found to be 10 kilonewton per meter square and 4 kilonewton per meter square. Just represent here, this is my sigma which is directly given and this is my tau. Okay. So, that means if let us say this is sigma and let us say this is tau. Okay. These two are given. Now, apart from these, determine the resultant stress. Okay. Simply it is asked to find out the resultant stress. So, resultant stress is nothing but root over sigma square plus tau square, that is okay. Now, the angle of shearing resistance. Here one thing you need to observe is that we need to find out the angle of shearing resistance, angle of shearing resistance and angle of failure plane. Here if you see theta, okay, if I just draw a 2-dimensional body, which is stressed due to the external loads, okay, which is stressed due to this external loads. So, I may obtain a particular failure plane. Okay. After some time, because of this external stress, there will be a small shear and there may be a failure along this particular plane. So, let us say it is making an angle of theta. Okay. So, this is known as the angle of failure plane. So, coming to angle of shearing resistance, this particular one, okay, angle of shearing resistance. So, what do we mean by angle of shearing resistance? Let us consider I have a particular amount of soil. So, take for example, I have a sand. Okay. So, what I am doing, I have this is a bag of soil, this is a bag of soil. Now, what I am doing, I am trying to dump it now. Okay, I am trying to dump it. So, what will happen if you look at the ground surface, if this is a ground surface, I am representing ground level. If this is a ground surface, if I pour this amount of soil, present it on the ground, so what will happen? It will try to form a heap like this. Okay. It will try to form a heap like this. Okay. So, this angle that is making is known as angle of repose. Okay, this angle is known as angle of repose, and this can be represented as some entity where we can find out angle of shearing resistance. Okay, this is some entity to determine the angle of shearing resistance. Clear? So, just make sure that this theta is different, angle of failure plane is different, angle of shearing resistance is different. So, how do we find out this angle of shearing resistance? We will look at it now. So, I have just represented this particular wedge with these forces for our understanding. So, initially we have to find out the resultant stress on the plane. So, let us say R is equals to root or sigma square plus tau square whole power 1 by 2. So, that is how we find out. And then coming to the angle of shearing resistance, we have learned that tau is equals to C plus sigma tan phi in our previous session. However, how we obtain this particular equation we will be understanding in our Mohr Coulomb theory. Okay. Here the particular phi, the angle of shearing resistance phi, if I have to say, just imagine there will be a particular generalized failure plane for a particular soil. This is a sigma and tau space. Okay. If there has to be, we know that tau is a function of sigma. We know that tau is a function of sigma because this is a tau sigma space. Okay. If I have to draw a particular failure planes along this particular one, let us say it is somewhat like this. For timing I am considering it as a curved one, or say it is a straight line. Okay. So, that means this equation of this tau sigma, tau equal to f of sigma is somewhat a straight line. So, that means we can obtain here tau is equals to f of sigma. Okay. So, that means this particular thing, okay, f of sigma is nothing but C plus sigma tan phi. How we have obtained we will learn in the next class, but for timing we have used this expression in GTE-II, that is why I have mentioned here. Here phi is the angle of this failure plane. Okay. Phi is this angle of this failure envelope. To more clearly tell, this is not failure plane, this is failure envelope. Okay. It is a connection of different failure zones. Okay. So, this is a failure envelope. So, phi is the angle of failure envelope and theta is the angle of the failure plane with respect to horizontal. So, this you need to keep in mind. So, that is how we obtain the angle of the failure plane as well as the angle of failure envelope. So, using this expression tau is equals to C plus sigma tan phi, now we need to obtain this angle of shearing resistance. So, here what we will try to do? First, initially we know that here tau is given as 4. Okay. Since it is a cohesionless soil, as I have mentioned, it is a cohesionless soil, that means C is equal to 0. So, simply take down this as C 0 plus sigma is given 10 kilonewton per meter square and tan phi. Okay. So, using this expression simply find out the value of phi. Okay. Now, so that is how we find out this particular thing. So, as I mentioned, as cohesionless soil C is 0. Now, let us look at some of the other questions. This till now what we have discussed is based on the initial principal plane concept. Now, we are not considering the principal lanes. So, let us look at the assignment in session 3 what we have discussed. So, these are the numerical questions that I have given. Okay. One is a numerical problem, the other one using a graphical representation. Let us try to understand this more clearly. Okay. So, looking at the first problem now. So, the normal and shear stresses acting on a particular plane are 80 kilonewton per meter square, 60 kilonewton per meter square and 40 kilonewton per meter square. That means, along a two dimensional body, if you consider, there are 3 stresses, sigma x, sigma y and tau xy. These 3 are given. Okay. Now, let us look at the wedge that I have drawn here. So, sigma y is given as 80, the maximum one, sigma x is given as 60 and tau xy is given as 40. You have to take them as a consequent way as it is given respectively. Now, we need to determine the normal stress, shear stress and resultant stress on a plane which is inclined at an angle of 30 degrees. That means, this particular one theta is given 30 degrees. Okay. So, we need to find out using this theta as 30 degrees and the value of sigma x, sigma y and tau xy, we have to find out tau and sigma on this failure plane AB. Okay. Now, so we know the expressions clearly when these are not principal planes for this case. So, we know sigma x, sigma y, tau xy and theta. Substituting these values, we get sigma and tau. Also it is asked resultant, so simply squaring and adding and making it as a root over, you will get r. R is equals to root over sigma square plus tau square. Now, apart from this, it is also asked determine the center of the Mohr circle. See, in the previous question itself I have discussed, sometimes it may be asked to find out the center of the Mohr circle. So, using this whatever expression we have to find out the center of Mohr circle and the radius of Mohr circle as well as maximum shear stress analytically. Okay. So, for this case also we have the expressions, that is the circle when drawn using these two expressions will have a radius of sigma y minus sigma x by 2 whole square plus tau xy whole square whole power 1 by 2. Similarly, its center will be located at a distance of or at a coordinates of sigma x plus sigma y by 2 comma 0. That means it is at a distance of sigma x plus sigma y by 2 comma 0 from the origin. Okay. Now, furthermore, let us look at the second problem. The similar problem we have to find out using the construction of a Mohr circle. So, here we need to understand that sigma x is given 60, sigma y is given as 80 kilonewton per meter square and tau xy is given as 40 kilonewton per meter square. So, first what we will do, we will draw x axis and y axis with the same scale. Let us say I am taking 1 unit is equals to 1 kilonewton per meter square or 10 kilonewton per meter square. Now, so what I will do initially, what is the value of sigma x? I will just mark down sigma x here. Okay. So, sigma x is at a distance of how much? 60 and sigma y is at a distance of 80. Okay. So, that we need to mark initially. Let us say as per our previous question, this is 60 kilonewton per meter square and this particular till r, this is 80 kilonewton per meter square, and then what we have to do, we have to mark the shear stress also. Say along the point Q, this is how much? 40 kilonewton per meter square. Similarly, drop down at this particular point, how much? 40 kilonewton per meter square. Okay. So, we have to represent this in this way now. So, as I have stated, we have to represent tau xy, this is 40, sigma x is at a distance of 60 and this is at a distance of 80. So, this will be 40. Now, join these two analytically and this will intersect at a particular point C. So, now since we need to draw just the Mohr circle, take SC and or CT as the radius and you draw the circle. Okay. Then that will intersect at S and T anyway. Now, so in that manner we have to obtain this values. So, here it is asked the radius. Okay. Simply you can just take the distance from here to here. This is my radius of the Mohr circle. So, in that way we have to find out the radius of the Mohr circle. So, when asked center, you if you know the distance from here to point C, then that means you can obtain the coordinates. If you look at this diagram, this is sigma 1 plus sigma 3 by 2. It is distance of sigma 1 plus sigma 3 by 2. Hence, the coordinates are sigma 1 plus sigma 3 by 2 comma 0. So, in that way we can obtain from this Mohr circle. Okay. Now, so that is what I have mentioned. So, when asked any failure plane, if asked in any question, just draw a failure plane making at an angle so and so or find out at a particular point, you can just use the concept of pole also. Clear? Now, so here it is asked the maximum shear stress, I have directly represented. Simply we can understand that if this is sigma 1 and this is sigma 3, what is the radius? Sigma 1 minus sigma 3 by 2 only. Okay. So, that is why if asked the maximum shear stress is also equal to the radius, the maximum shear stress will be equal to the radius only. So, that is why it is sigma 1 minus sigma 3 by 2. Clear? So, in that way we have to obtain. Okay. So, this is coming to our solving the problems. In the upcoming lecture, we will try to understand the Mohr-Coulomb theory. as we have discussed in one problem in session number 2, where tau is equals to C plus sigma tan phi, we will understand how the concept of this particular equation has been obtained. So, that is we will understand by Moore-Coulomb theory. Okay, we will be understanding by Moore-Coulomb theory. Okay. So, that is it for today. Thank you very much for this particular lecture.